Welcome to List Comprehension lecture. So list comprehension is an elegant way to define and create a list in Python. It relies heavily on for loops and significantly reduces the lines of code needed. And with less lines of code means less chance for error. So let's start off with our typical for loop, where we're going to have a variable called cosmos equal to an empty list, and then we're going to do for I in a string called universe colon. We'll do cosmos dot append I, and then we'll run the outputs. And as you can see here, we have a total of 8 strings, which are each of the letters from the string universe. Okay, so that is a total of 4 lines of code. And how can we do this with a list comprehension? Well, when we do list comprehension, we always start off with square brackets, and then we do, let's say, u for u in universe. And we have the exact same output, but with only 1 line of code. So it's far less chance of error with a list comprehension, though it's somewhat less readable, and as a consequence, for people who want to make their code readable to those who are not familiar, it's perhaps best to use this above method as opposed to the list comprehension. There's even a simpler way than using this list comprehension, and that's to do list universe, and you get the exact same output. However, this is limited to only a single string, and unlike with list comprehension and the for loop, this method here is just based upon strings. Okay, so moving on, just going to scroll down, and let's say we do norm equals an empty for n in range 0 to 11 colon, say results equals n raised to the power of 2 norm dot append results, and then we'll do norm. And as you can see here, what's happening is that it's grabbing all of the numbers from this range, which is 0 to 10, and that's raising it to the power of 2. So for instance, if we did not do to the power of 2, it would just be 0 to 10. We just undo that. So as you can see, it's basically 10 multiplied by itself, which gives 100. 9 multiplied by itself gives 81, and so on and so forth. So how would we convert this into a list comprehension? Whereby we have, if you hit on the white space here, hit L, 5 lines of code, which is quite lengthy. So we can do this all in one line. Let's do X. So we do the calculation here for X in range 0 to 11. And as you can see, you have the exact same output. And what we can also do is assign it as a variable, comp, and then we do comp, and you have the same output. Okay, so moving on from that, just scroll down, and now we'll do a list of pets, and we'll say cat, dog, rabbit, duck, mouse, doesn't matter if it's uppercase, and let's say, whoops, and let's say piglets. Okay, just make that a bit clearer. Pets, there we go, and that's kind of bugging me actually, the uppercase, so just make that M, lowercase. And let's say we do raz equals empty. We'll do for I in range len pets colon res equals pets I, so we're selecting the index of pets one at a time, and plus is hungry, and then we do rads dot append res, and then we do the output of rads, and if we just hit here, okay, so we've got cat is hungry all the way down to piglet is hungry. So if you ignore these 2 lines here, we have a total of 4 lines of code, and we can of course do list comprehension, whereby we can just do that with 1 line of code. So we start off with square brackets, and what we do is pets I for, or rather we do pets plus is hungry for I in range len pets. There we go. So it's the exact same effect, or the exact same output, and it's far more elegant than the typical means of going about writing a for loop. And generally, Python is arguably the most elegant language out there compared to all the others. Okay, so moving on, let's say we do numbers, raise that to the power of 3 for numbers in range 0 to 11. So nothing exciting here, but what we can also do is a condition. So if numbers is greater than or equal to 8. Great, so 512, 729 to 1000. And if we were to convert this list comprehension into a for loop, what we can do is count empty for num in range 0 to 11, colon, oops, it's colon, not semicolon. If num greater than or equal to 8, put a colon there, new equals num raised to the power of 3, or cubed, you could say, count.append new, and then we do count. And you have the exact same output. And as you can see, we have a total of 6 lines of code. So this is far more inefficient than the list comprehension. And what we can also do is, let's say if num is greater than or equal to 8, and let's say numbers modulus 2 is equal to 0. Let's just change this to something else. Let's say 3. As you can see here, we have 64, 216, 512, and 1000. So we don't have the 729 that we had before. If we were to change this, got different outputs. So it's all of the odd numbers that have been cubed. Okay. And of course we can do the same here with just simply and num modulus 2 equal to 1, and just change this to this here, of course, to 3, and have the exact same output. Okay, so as you can probably notice, when we're doing a list comprehension, what we're doing is ignoring this here. We don't need this because we're already in square brackets, and also because we're in square brackets, we don't have to use the append function. And as you can see here, the if num greater than or equal to 3 and num modulus 2 equal to 1 is essentially the same as what we have here. Instead of num, it's numbers, and with the if. So all of this line here is essentially the same as this line here. And we have the 4 numbers in range, which is what we have here, but without the semicolon for the list comprehension. And then you have the numbers cubed, which is here. Okay, so moving on from that, what we're going to do now is, let's say growth equals empty for grow in range 0 to 20, colon, if grow modulus 2 is equal to 0 and grow is greater than 2, colon, growth dot append grow, and we'll do growth. Great, so you have 4 all the way to 18, and if we were to do list comprehension here, g for g in range 0 to 20, if g modulus 2 is equal to 0 and grow, or rather g, is greater than 2. Great, okay. So that concludes my lecture on list comprehension. If you have any questions, feel free to ask, and I look forward to seeing you in the next lecture. Thanks.